So now we'll be talking about the BGP, the Border Gateway Protocol. What is a BGP? How it is different from other protocols like OSPF or EIGRP? BGP is used by the ISP, Internet Service Provider, and it is a crucial protocol in the world of networking, and it enables the exchange of the routing information between the different AS. What is an AS or the autonomous system? It is a logical boundary like the EIGRP or the OSPF uses, and you will find different routers residing inside the AS. And AS is further divided into areas in case of OSPF, but in BGP we see the AS only. It plays a vital role in maintaining the stability and efficiency of the internet by ensuring that the traffics are routed in some optimal way. Like BGP has some best path selection methods that we will discuss later. So is ACE is like it is minimizing the routing updates that the BGP sends. So if you put all the routers in the same ACE, definitely it will create some bandwidth issue. So we have to divide the ACE. Border Gateway Protocol is the protocol that facilitates the exchange of routing information across the internet. This is the routing protocol for the ISP. This is not the protocol that is used in the enterprise environment or the companies. It is the routing protocol for the internet, and it enables different autonomous systems to communicate. So as a core component, BGP ensures efficient data packet delivery through dynamic path determination, and this is actually a protocol that can actually carry a lot of prefixes or the network layer reachability information, NLRI that we say, and millions of NLRIs it can actually support, but not the case of the OSPF or the EIGRP. So we cannot use the OSPF and EIGRP as the routing protocol for the ISP. So what is the BGP's role in internet routing? First of all, it connects different autonomous systems together. So BGP connects multiple autonomous systems or ASs together, which are large networks or group of networks under a common administration or common administrative body. And this interconnection is crucial for the overall functionality of the internet, allowing different ISPs and organizations to exchange the routing information very effectively. So all the entities they exchange the routing information effectively under the BGP. Secondly, it ensures optimal path selection. BGP plays a vital role in ensuring that data packets they take the most efficient and optimal paths, and you can evaluate various routes based on different metrics. Means BGP doesn't have only one metric like the EIGP has bandwidth, OSPF has cost, and BGP has different metrics like the ACE path, local preference, weight, MED, different attributes are there. So BGP contributes to minimizing latency and improving overall performance by using these all attributes. So these factors or these, let's say the metrics have made the BGP as the most efficient protocol. It maintains the routing stability by maintaining a stable and efficient routing environment. BGP has to prevent routing loops, and it ensures quick convergence in case of network changes. So this stability is essential for maintaining the reliable internet connectivity. So what are the BGP terminologies? First is the autonomous system or the AS that I've already talked about. This is a logical boundary area, a guided area where all the routers reside. The root, the prefix or the NLRI, network layer reachability information, and path vector protocol. This is called as a path vector protocol because it has some different metrics. So different for creating the best path, it uses different metrics. That is why it is path vector routing protocol. So this is about the basic understanding of the BGP. And now I will take you to the JSC console to configure that. So now let me take you to the JS3 console, and you can see that R1 and R2, these two routers are directly connected, So you just go to the R1 console, for example, and we are connected with simple interfaces like view, show, or hide interface of F0 by 0. So go to the console, give the IP first, and now create the loopback interface. Say 10.0.0.1 and 255.0.0.0, and now go to R2, IP address 192.168.0.2. This is 20.0.0.1. So now, when configuring the IP address is complete, now just go back to the config mode, and now you can configure the BGP, but you have to configure a BGP router ID. That is very important. Router BGP, and this is the autonomous system number, let's say 10, and this is the internal BGP or IBGP that I'm configuring first. Later on, I will configure EBGP also. Internal BGP means all the peers, all the routers will be in the same ACE. And router ID, or rather BGP router step, is not taking the router ID here. So let's go to the BGP and let's check the router ID. You can see that is there. So it would be router hyphen ID, say 1.1.1.1, this one, and in R2, router space BGP, then is 10, and BGP router hyphen ID 2.2.2.2, and then you specify the neighbors. Neighbor should be the other one, that is the IP address of this R2, and that should be, you can give the loopback, but in that case you have to give update source loopback 0. So I'm not going to do that. I'm going to build relationship with this physical interface only, that is 192.168.0.2. So neighbor would be my 192.168.0.2, and the remote AS would be 10, the same as. And here on R2, its neighbor would be the 192.168.0.1. Remote AS is again 10. So on both the routers, I provided the information of the neighbor, and I also have to advertise, and you can see the neighbor relationship is up. So it has found the neighbors, and you have to advertise your networks, that is both the networks that you're having, like 192.168.0.0, and mask would be the exact mask, that is 255.255.255 or 0, and the network, that is loopback, that is N000, and the mask means the subnet mask, that should be exact, this one. And on router 2, network again 192.168.0.0, and mask would be 255.255.255 and 0. And the other network as 20.0.0.0, and mask would be 255.0.0. So these things are advertised in the BGP network. So now if I go to R2 and see, I give the command show IP route, you can see the BGP there, that is this one dot zero. And if you give show IP route BGP, if you filter out only the BGP route, this is the BGP route that you can see. And on R1, show IP route, that is 20.0, or show IP route BGP, if you give that is a 20.0. Alternatively, you can see the BGP's routing table with show IP BGP. There you can see all the networks that's advertised, and 10.0, 20, 192, and this is I for internal BGP, and asterisk means this is the actually this is a valid, this is the best path, and this is the next stop. Next stop is the other router. Let's see. And you can see the metric, local preference. These things are the metrics of the paths. And on R2 also, you can check it out with show IP BGP. There is the BGP's routing table. And you can see that the 10.0, 20.0, and 192.160, all these are dice there. So this way we can configure the simple IBGP or the internal BGP configuration within the same AS. So that is about the internal BGP. I will see you in next video.